How are you today? Welcome back to our online class. This is your teacher, Aurora Gundan. And our topic for today is illustrating mutually exclusive events in grade 10 quarter 3. For two or more events, it is important to understand how they are related before finding the probability of one or the other event occurring. So, mutually exclusive events are events that cannot occur at the same time. Two events are said to be mutually exclusive if they have no outcomes in common. The set are disjoint events or they do not intersect. The probability that either event A or B occurs is the sum of their probability. Let's look on our Venn diagram. So clearly, we have sets A and B, and there is no common intersection or there is no intersection between sets A and B. Okay, so the probability of A or B in symbol, we have here the probability of A or B is equal to probability of A plus probability of B, whereas the intersection is a null set. Let's have example number 1. Suppose you draw a card from a standard deck of 52 cards. What is the probability of drawing an ace or a king? So for our simplicity, okay, we have here the probability of ace. Okay, simply the probability of ace, there are 4 aces in out of 52. Okay, that is the standard decks. Also, the probability of king, so that is B, or probability of king is equal to 4 over 52. Because there are 4 kings in the standard deck, so take note that the probability of both events is equal to the null set. Because since a card cannot be an ace or a king at the same time, so the events are mutually exclusive. That is, the two events cannot happen at the same time. So we go further, so the probability of drawing a king or a queen is equal to probability of drawing a king plus the probability of drawing a queen. So that is 4 over 52 plus 4 over 52. So this is equal to 8 over 52, or in lowest term is equal to 2 over 13. Therefore, the probability of drawing a king or a queen is 2 over 13. For the meantime, we will express our probability in a fraction. Sometimes it can be expressed in decimal form or in percent. Okay, to summarize our concepts of probability of mutually exclusive events, so if two events A and B are mutually exclusive, then the probability that either event A or B occurs is the sum of their probabilities. In symbols, so that the probability of A or B is equal to the probability of A plus probability of B, or the probability A union B is equal to the probability of A plus probability of B, which means that their intersection is equal to 0. Okay, to help us better understanding of the mutually exclusive events, so let's have this example. So the event of getting a number divisible by 2 or the number divisible by 5 from the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is an example of a not mutually exclusive events, because if we are looking to this one, since a subset of a number divisible by 2, which is 10, is also subset of a number divisible by 5. Two events A and B are said to be not mutually exclusive events if they can occur at the same time. So let's look on our Venn diagram. Clearly, okay, this is the set of the multiple of 2. On the other hand, this drawn circle is composed of set of multiples of 5. So clearly, there is a common element between the multiple of 2 and 5, which is 10. Beside from that, the numbers 1, 3, 7, and 9 are outside the multiples of 2 and 5 because they do not belong to either the multiple of 2 or multiple of 5. Moving on, so if you want to find out the probability of A or B, that is, the probability of A plus the probability of B minus to the probability of A and B. Clearly, so we have here in symbol probability of 2 or 5. So we can look in our video or Venn diagram, there are 5 elements out of 10 to satisfy 5 over 10. Next, the probability of B. So there are 2 elements in B. So we have here, okay, 5 and 10. So that's why 2 over 10. Next, so the probability of A and B, this is the probability of their intersection. So there is common elements out of 10. That is why 1 over 10. So this further, so that actually 6 over 10, that is fraction. 6 over 10 or in decimal 0.60 or 0.6, or this is equal to 60%. So let's move on to problem number 2. Francis has 3 white balls, 4 green balls, and 5 red balls in his box. He takes a ball from his box at random. What is the probability that it is a white ball or a green ball? Again, so the probability of white that is in symbol P of A is equal to 3 out of 12. There are 3 white balls out of 12. So the probability of green, that is P of B, that is equal to 4 all over 12. So take note that the probability of both events is equal to 0. Okay, since a ball cannot be a white or green ball at the same time, the events are mutually exclusive. So again, the probability of drawing a white or green ball, this is equal to the probability of drawing a white ball plus probability of drawing a green ball. So we add in 3 over 12 plus 4 over 12. So this is equal to 7 over 12. Therefore, we can say that the probability of drawing, okay, a white or green ball is equal to 7 over 12. Let's move on to problem number 3. So one die is tossed. What is the probability that it shows a 2 or a 6? So if you toss a die, the number that would come up could be 1, 2, 3, 4, 5, or 6. There are 6 possible outcomes in all. Therefore, the probability that it will show a 2 is 1 out of 6, so with the 6. In simple, so that is probability of 2 or 6 is equal to 1 over 6 plus 1 over 6, okay, or that is 2 over 6 or equals to 1/3. So this is the same as 0.3333 or this is 33.33%. Since if we will put into Venn diagram, it is exactly this is 2 and this is 6. Clearly, there is no common shaded part between 2 and 6. Take note that 1, 4, 5, and 3 are outside this circle. Therefore, we can say that these events are mutually exclusive since they do not have outcomes in common. That ends our discussion, and do hope you were able to understand our lesson illustrating mutually exclusive events. Again, this is your mathematics teacher, Aurora Tigundan, signing off.